All right, let's jump straight into a truly mind-bending thought experiment today. What would actually happen if gravity just ceased to exist? I mean, we go through our daily lives completely taking for granted this invisible force keeping our feet planted firmly on the ground. But in today's explainer, we're going to break down the sheer, terrifying, and honestly awe-inspiring cascade of events that would unfold across our biology, our planet, and even our solar system if we suddenly experienced a total gravitational discontinuity.
So, imagine if the gravitational constant, big G, just plummeted to exactly zero right now. This constant is quite literally the bedrock of physics, right? It dictates the attraction between any two masses. If it vanished, the physical laws binding our bodies, the Earth, and the stars together would just instantly unravel. We wouldn't be peacefully floating around like astronauts in some sci-fi movie. No, we'd immediately face an environment completely hostile to the fundamental blueprints of life and planetary structure.
And the timeline for this is incredibly grim. Just look at the catastrophic first 90 seconds for a human exposed to a zero-gravity environment right here on Earth. Why a vacuum? Well, without gravity, Earth's atmosphere has no anchor, so it instantly expands and just slips away into the void of space. In the very first second, you'd feel weightlessness. But by second 5, that rapid drop in ambient air pressure causes severe trauma to your inner ear. Hit second 12, and your blood rapidly deoxygenates. That's hypoxia. Then, within a minute, you reach ebullition. This is where the lack of pressure causes the water in your soft tissues to literally boil and vaporize at normal body temperature. By 90 seconds, it's total circulatory failure.
But, let's just pretend for a second that you had some magically pressurized, oxygenated suit when gravity disappeared. Even if you survived the vacuum, you'd immediately get hit with space adaptation syndrome. See, your inner ear contains these vestibular organs that rely entirely on gravity to tell your brain which way is down. Take away that signal, and your brain suddenly gets wildly conflicting information from your eyes and your ears. The result is intense, absolutely debilitating nausea and spatial disorientation. Basically, your own sensory system completely turns against you.
And then there's the massive physiological shift, specifically the total loss of your downward hydrostatic gradient. Normally, gravity's pulling your blood down into your legs, and your heart is working super hard to pump it back up. Take gravity out of the equation, and all that fluid rapidly rushes straight up into your chest and head. This causes what space medicine actually calls moon face puffiness, and the pressure on your optic nerves completely blurs your vision. Your body senses all this excess fluid up top and responds by actually reducing your total circulating blood volume. That leads to severe orthostatic intolerance, which means your cardiovascular system basically forgets how to function properly under any sort of pressure.
Meanwhile, there is a terrifying cellular battle happening deep inside your skeleton. Our bones need the constant mechanical stress provided by gravity to stay strong. Without it, osteoblasts, those are the cells responsible for building bone, they just completely shut down. But at the same time, your osteoclasts, the cells that break bone down, they go into absolute overdrive, increasing their activity by up to a staggering 197%. You'd quickly develop severe spaceflight osteopenia, losing 1 to 2% of your bone mass every single month, flooding your bloodstream with calcium and just drastically weakening your entire structural frame.
And if we look out into the animal kingdom, the chaos is just as bad. Without that gravitational anchor, invertebrates completely lose their spatial orientation. If you placed fish or tadpoles in this zero-G environment, they just swim in these confused, endless loops, desperately trying to use the direction of light as a substitute for up. And tragically, studies have shown that mammalian infants fail to huddle for warmth and comfort, just helplessly drifting apart when they need physical contact the most. It really drives home a profound point. Terrestrial biological blueprints are deeply, intricately hard-coded for a 1G environment. Life literally does not know how to exist without it.
So, that's the biological side. But what happens on a planetary scale? Because gravity isn't just holding down our atmosphere, it is actively holding the actual rock of the Earth together, constantly fighting against the immense centrifugal forces generated by the planet's rotation. We're essentially living on a planetary pressure cooker without a lid.
Now, the absolutely crucial point here is that Earth's inner core is sitting at an unimaginable 5,000 degrees Celsius. I mean, that's hotter than the surface of the sun. And the only reason this core remains a solid ball of iron and nickel is because of the crushing gravitational pressure of the entire planet pressing down on it. Without gravity, that immense pressure vanishes in a split second. The core rapidly undergoes an explosive phase transition, flashing from a solid straight into a liquid or gas.
So within just 1 hour, the timeline for our home planet looks roughly like this. First, as we lose atmospheric pressure, the oceans boil and vaporize instantly.
Next, that rapidly expanding core and mantle push the tectonic plates violently outward. Seismic shock waves start rippling through the crust at several kilometers per second, completely fracturing the surface. And finally, driven by those expanding internal forces and the relentless centrifugal spin of Earth's rotation, our spherical planet just dissolves into a chaotic, rapidly expanding cloud of rock, magma, and gas. Earth is, for all intents and purposes, gone.
Now let's scale things up even further to astrophysics and look at the sun, because stars, for all their immense power, are actually incredibly delicate balancing acts. They are massive fusion reactors that are held in check entirely by their own gravitational weight.
The sun exists in a state called hydrostatic equilibrium. Deep in its core, temperatures hit 15 million Kelvin, generating massive thermal and radiation pressure that pushes outward. So you might wonder, why doesn't the sun just explode? Well, it's because that immense outward pressure is perfectly matched, point by point, layer by layer, by the crushing inward pull of the sun's own incredible mass. It is a perfect, self-regulating stalemate.
For the physics students tuning in, we can mathematically map out these forces by looking at a simple spherical mass shell. Let's call the mass dm and give it a thickness of dr. Think of this shell as just one tiny layer of the sun. For the star to remain stable, the pressure pushing up on the bottom of this specific shell has to be exactly strong enough to support the weight of all the gas pushing down from above it, plus the gravitational pull pulling it toward the center.
And this balancing act gives us the stellar structure equation. Now, it might look a bit complex, but it tells a really beautiful story. The term dp over dr represents the pressure gradient, basically how the pressure changes as you move outward from the center. It absolutely must be negative, which is why there's a minus sign there. It means pressure has to decrease the further out you go. This outward push perfectly counterbalances the gravitational pull, represented on the other side of the equation by big G, the mass, and the density, all divided by the radius squared. If you take away G, this entire equation breaks down, and the star itself literally falls apart.
Now consider the number 1800. In astrophysics, this represents the freefall timescale, measured in seconds. This is the exact amount of time it would take the sun to completely collapse in on itself if you magically turned off its internal thermal pressure. That's only about 30 minutes. But conversely, if you turned off gravity, like in our zero-G scenario, this exact same timescale dictates how astonishingly fast the sun's internal pressure would violently blast its mass outward into deep space.
As the sun explosively expands without gravity holding it together, the density of the hydrogen plasma in its core just plummets. You see, nuclear fusion relies on incredible density to force protons together against their will, which is what allows quantum tunneling to occur. But as the star expands and the density drops, those protons spread too far apart. Quantum tunneling stops, the nuclear fusion reaction completely crashes. Just like that, the greatest energy source in our solar system goes quiet, and the star simply fades to dark.
It's profoundly humbling when you really sit back and think about this. Every single aspect of our reality, from the calcium binding the bones inside your body, to the liquid water in our oceans, right up to the burning of the stars in the night sky, it all depends entirely on the unbroken pull of this single, silent constant. So, after seeing exactly how quickly our entire universe would unravel without it, doesn't it make you look at the simple act of standing firmly on the ground just a little bit differently?